I'm very excited to welcome Professor Tanona from philosophy. He's a philosopher of science, and he deals with ethics and just other issues. And I think he'll be an excellent addition to our program. Thank you. Please join me in welcoming Scott to our class.
Thanks. Happy to be here. Yeah, so I work on a variety of different things dealing with science, interpretations of science. I started out working a lot in physics and interpretations of modern, quantum mechanics and things like this, but have been doing a lot of work in science and society, the role of science in society, science and ethics, ethics of science communication, things like that. What I'm going to do today is just provide a bit of a actually it'll be kind of a simple overview of a bunch of issues in thinking about the role of science in society and in setting policy, but also ways in which values, and sort of it's going to be a lot about values, and it's also going to be ways in which values show up in scientific decision making in ways in which we might not always recognize. Okay, so on the one hand, it's going to be not super detailed. I'm going to go for breadth here, right? So what I want you to do is sort of get a big picture and try to sort of get a sense of things that you might already be thinking about and recognizing, sort of a general framework to be putting them into, and what would be good is for you to see if you can identify ways in which, oh yeah, here's this thing that I've been thinking about, or here's this thing that we were just talking about, and it kind of fits in here, right? And then that helps you, I will hope, is the goal for what I'm going to do, give you sort of a broader context of how to think about those things, yeah? Okay, so what I want to start with, this was working a minute ago. No, it's not. I'll go back over here then. I want to start with sort of a basic definition of what I mean by values. So values are evaluative things, right? Distinguish them from facts, right? There's a fact-value distinction, right? So values are our preferences, what we would like to see about the world, right? Anything along those lines, right? The standard distinction sort of simply is versus ought. Is the way things is or are, right? And ought is the way things ought to be, right? So, you ought not eat a steak well done, right? That's a preference that I have. That's a value that I have, okay? Why is this important? Oh, so one thing that's important to say, values aren't just the same as opinions. We can have opinions about facts, right? What do you actually think is likely to happen tomorrow? That's predictive, it's a prediction. You have opinions about sort of what you think about a particular state of science, right? Or, whatever, but that's different, right? So you can have opinions about facts, and you can also have opinions about values, okay? So not the same thing, okay? And this still isn't working. All right, so one of the questions is, what's the role of values in science? And there's a very kind of old, but I still think standard way of thinking about science is that science doesn't deal with values, right? So values are other kinds of things. Values might come in when you're choosing projects, like how much money do you want to invest in cancer versus sort of environmental research versus, whatever else, right? And then, in applications, once you've learned something, right, okay, what are we going to do with this, right? And then there's constraints on the science that's done. You can't do certain kinds of experimentation. That's a value-laden thing, right? But the science itself is objective and neutral, right, and doesn't truck in values, all right? I mean, this is a standard view, right? I don't think it's the right view. I hope you don't think it's the right view, but it infects us, and a lot of times, even if you sort of recognize that there's ways in which values play a role in the actual doing of science, what I want to do is highlight some of those and sort of, talk about them in ways in which they show up, possibly in ways we don't always recognize, okay? And so let me point out sort of one of the big ways of thinking about this. So William James, he was responding here, so this is now an old quote. In this, he was responding to a critique about religious faith, where this person, Clifford, said it's always wrong to believe on insufficient evidence. And so he was critiquing belief on the basis of just faith, right? And he went into sort of a whole series of things. You don't have to know the context. But one of the things James said is like, whoa, slow down here. Because what Clifford was saying is like, well, look, you jumped in and you believed something, but what if you were wrong? Like, bad things could happen from that. And what James pointed out is, well, that's one way of being wrong, but there's another way of being wrong. If there's a fact out there in the world and you don't believe it, right? Now, we don't think of that always as being wrong, but it's a failure of aligning your beliefs with facts about the world. there's two ways in which your beliefs can fail to line up with the world. One is you can have a belief in your head that's false. The other one is that there can be a fact in the world that you don't believe, right? And both of these can be important. So, I mean, his critique then to, Clifford about religion was, oh, well, wait a second, if there is a God and you don't believe it, well, that's got consequence too, and so, he went into all these other, but put aside the religious context, what I want to do is put that same bit into the scientific context. Now, we know about this. I mean, sort of we have words for these, type 1 and type 2 error, false positive, false negatives, right? So standard statistics, right? So type 1 error we pay a lot of attention to. You set your alpha level. You sort of say, hey, look, if my null hypothesis is actually true, what's the probability of seeing something like this if in fact there's nothing going on, right? And that's supposed to give you a sense of thinking about your type 1 error, right? Well, there's also the type 2 error, which is what if the null is true? Sorry, I just did that, so the null is true. So wow, that's funny. Right, okay, so actually, and the reason this is funny is because null hypothesis testing is backwards in a number of ways, right? Sort of what it does is you're looking to test the alternative. You're trying to find out the alternative, but you only do it by falsifying the null, right? So the type 1 would be the null is actually, right, true, but you went and believed, right, that it wasn't. Type 2 would be that it isn't true, but you didn't have enough information, right, to then say it wasn't true, right? And so there's a fact out there in the world, like your medicine works or whatever, right? And you didn't conclude it because you didn't have strong enough evidence, okay? Both of these are failures to align, right? So and let's just put this in terms of you believe or we think we know something, right? Some statement X, right? There's two ways in which you can go wrong, right? So if you believe something that's true, that's great, right? And if it's false and you didn't believe it, that's also good. You avoided error, right? And then there's these two things where your belief doesn't line up with truth, right? Now, we can talk more about standard null hypothesis significance testing and ways in which it sort of biases us in one direction versus the other, especially given the ways in which a lot of it's always paid attention to just setting an alpha level and looking for a p-value and sort of not paying as much attention to power as we maybe should if you're worried about sort of other issues. But I want to look at sort of more subtle ways in which type 1 and type 2 error can show up. And actually, but even before we get to that, think about the value question, okay? Which is more important? Which do we really want to avoid? So, a lot of science, I think, is set up with this intention of trying to avoid type 1 error, right? Now, if you're in high energy physics, this is really true. You wait for a 5 sigma event before you declare yes, we finally know something, right? And you get lots and lots and lots of evidence, but you're oh, we're not sure yet, right? And you get more evidence, and oh, we're not sure yet. You need you need a really far out. Whereas, in a lot of other fields, you wait for a 2 sigma, right? Sort of p less than 0.05 event, right? And then you're hey, look, I found something, right? All right, so, but in any case, we're kind of pay a lot of attention to that error, right? What if I'm wrong? You declare something, right, and you're wrong, all right? Well, let's just talk about the weighing of these two types of errors outside the context of science first. Right? What about criminal court? Which is worse, a type 1 or a type 2 error? Now here, actually, we have to sort of be a little attentive to sort of the complexities of this, right? The way I'm talking about a type 2 error is here you just didn't believe something that's true. And there's two ways this can go, right? So you can believe somebody's innocent, or you can believe that they're guilty, or you could be totally agnostic, and so you're not sure about either. And so there's actually, there's two types of type 1 error you could make, right? And there's two types of type 2 error that you could make, right? And so it kind of gets a little complicated. But let's just sort of, think about the trade-off of the consequences. You declare somebody guilty versus you don't, right? What would be a type 1 error there? It's declaring somebody guilty. Oh, that's really bad, right? Why? Because they go to jail, right? They lots of things. They in certain states you never get to vote, even once you're out of jail if it's a felony, death penalty, whatever, all kinds of issues, right? Well, what's the type 2 error there? Somebody's guilty, but you didn't put them away, right? Oh, well, that's bad too. Well, which is worse? Well, our criminal justice system is set up to really try to avoid that type 1 error, right? Why? Because we think it's a real tragedy of justice to put an innocent person in jail. We really, really want to avoid that, right? Now, I mean, if you're a cop or you're a prosecutor, you start to really worry about the type 2 errors a little bit more, and there's supposed to be a balance of like how we handle this stuff. But one thing I want you to note is, I don't know if you've paid attention to this, civil court has a very different standard, right? Civil court's a preponderance of evidence kind of standard, right? Sort of you sue somebody else, it's not proved beyond a reasonable doubt, it's, what's the strongest evidence, right? On which side, right? And at least one reason is that, well, the consequences are different, but also there are two parties involved here. So like, finding wrongly on the version of one, you have to contrast that with sort of a failure to make somebody right, okay? Well, let's expand this out. Pregnancy test, which would be worse, right? Type 1 error, type 2 error. I don't know, do we think about this a lot? Sort of, process that a little bit, so type 1 would be you think you're pregnant but you're not. Type 2 would be you don't think you're pregnant but you are. Well, geez, we typically want to avoid the type 2, but type 1 error, thinking you're pregnant, you take a test and it says you're pregnant and you're not. Well, that's got consequences, right? You don't want that. It's certainly if you're the manufacturer of the pregnancy test, you don't want that to happen. Cancer screening. So this is a really important one to think about. So a lot of cancer screening has previously been really based on the idea that you don't want to have cancer and not catch it. You don't want to be in a type 2 situation where there's this fact that you don't know, right? Because that would be really bad, right? But type 1 are false positives, right? So that would be a false negative or, right? So false positives are also bad, right? There's lots of risk, right, associated with follow-up tests. There's lots of expense followed up with follow-up tests. And in fact, for some things, this is right, the recommendations for screening for prostate cancer have changed, right, partly because of the consequences of false positives. And so now people are sort of like, well, wait a second, we have to pay attention to that too. This is a value question. It's a value question about which of these two things are you most worried about. Now, you're going to assess this in terms of the consequences. What's the money? What are the health consequences, things like that. But then you're making evaluative choices on those too, right? Like, how much do we worry about having cancer and not catching it versus sort of the other things? You have to weigh those off, okay? And there's a lot to think about in terms of drug approval, environmental regulation, things like this too, right? Sort of drug approval, you want things to be safe, but on the other hand, if there's a real medical necessity, maybe you don't want to be sitting on a drug that's safe and not know it's safe if there's things that you can do in the meantime, okay? This is all weighing, all right? So that's the value question, yeah? And note here, there's two different values. Well, there's two different instrumental values. There's other things that we care about, but the two ways of being wrong, the type 1 or the type 2 error, are two things that you're going to value independently on the basis of these other consequences, right? Okay. And they trade off. You can't minimize both. And you shouldn't just think, oh, we should try to balance them equally, because it all depends on what the consequences are, yeah? Okay, so let's just talk about ways in which things that we're doing in science can influence type 1 versus type 2 error, even if we're not thinking about it, not in terms of application, not in terms of, right, sort of, but in the science, all right? So this is a case from that Heather Douglas talked about in a philosophy of science paper in a 1990 reevaluation of some liver slides looking to test the effects of dioxin, the toxicity of dioxin, in particular, sort of whether it was carcinogenic. Actually, just talks about toxicity. I should sort of go back and look at that case. No, so tumors too, that's right. So there's two things that they were looking at. One of them was sort of a number of effects on the livers and then sort of tumors, okay? And there was a reassessment that was done in 1990 of the very same slides that were collected by this one study in 1978. They applied a different standard to it, and they came up with a different set of answers in terms of, right, so the malignancy rates. But more importantly, let me note the following thing. One of the ways they tested this was with sets of pathologists with the very same standard who looked at the very same slides, and they came up with different answers about sort of whether a particular tumor was malignant or not. Right? And now this is actually kind of, my understanding, fairly common, right? This is a subjective determination, even though you've fixed a particular standard about what it means for something to, right, sort of to determine something malignant, right? There's a subjectivity in here. And that subjectivity can influence your type 1 or type 2 error, right? So if you're more cautious about declaring something to be, right, malignant, well, then that's going to have an effect on, right, that affects your data, right? And different people have different views here. This 1990 reevaluation did result in a loosening of regulations in Maine, right, on dioxin, which was important for paper companies. Here's another case. This was a case for study of BPA. And it was looking at the effects of BPA dosage at various levels. And one of the things that's pointed out here is that there's, at this point, there is a whole, well, there are 11 studies funded by chemical companies that were surveyed here, none of which indicated a harm of BPA, whereas a bunch of the government, most of the government studies had. One of the things that was noted here is like, why? What's going on here? There's two separate things that went on here apparently in most of these chemical studies. One of them is they were using a strain of rat that was apparently not very sensitive to estrogen and estrogen mimicking drugs, which was sort of the mechanism via which BPA, right, causes toxicity. And then another issue was there are indications that the dose response curve for BPA looks kind of like this, right? The effects ramp up, but sort of once you hit a certain dosage, there's mechanisms in the body to start sort of counteracting them, and the effects go down, right? Now, standard assumptions a lot of times about testing sort of assume at least a monotonic curve, sort of always increasing, right? And often assume a linear curve, sometimes thresholds, but you know, whatever, right? So now here's this question, sort of how do you design your study? What doses are you looking at, right? A lot of the studies that they were looking at actually sort of were up here, and they're like, well, look, see, it doesn't do anything at this high dose, so like it's going to be safe at lower doses. Well, not if this is the dose response curve, right? So now on the one hand, there was like what looked like an apparently good bit of science. Here's my model organism, right? Here's the doses that we're testing. No effect. Like on that basis, like, you know, as far as I know, there was nothing like wrong that happened in the study. There was no fraud, there was no faking of data, there was no, right? But the setup of the experiment was not such that it met the actual values and goals for this particular situation, right? Okay. That's just an example of this kind of thing. All right, so how do we trade off, right, on thinking of these? So sort of what are we really worried about? How cautious do we want to be, right? As we're doing our experiments, what little ways in which we are making our observations, right, or we're doing an interpretation, or, you know, we're whatever, which data we throw out legitimately, because you can, like, you know, outliers are certain, right, you can do certain, right, which of these things are like shifting, right, the results one way or another. And there's a tendency, I think, a lot of times for people to think, well, the science should be cautious, right? You don't want to jump to something, but like that's weighing your type, you know, the errors in one direction, right? You want to be paying attention to sort of the other direction. Are you being too cautious too, right? And in any way, you want to pay attention to the many ways in which little bits can be going. So, like, you know, for example, right, sort of, you know, the testing of, you know, something like, right, the effects of, right, the predominance and the effects of plastics in our environment, right? Sort of like, you know, sort of what kind of, how do you want to trade type 1, type 2 error here, right? You know, and how do you want to think, sort of like, sure, in terms of policy and stuff, but in terms of any, you know, study that you're going to do. Let me talk a little bit more about the cautiousness, and let me sort of give one view about sort of an extreme version of being skeptical. And I say this because I think So the sociologist Merton back in the 1970s characterized sort of different values of science, and one of the things he said is that sort of, look, science has an organized skepticism, right? The way we approach things is kind of, you know, you critique potentially anything, right? You don't believe without sufficient evidence, you know, et cetera, right? Well, I mean, this is all good, but part of what I just indicated are ways in which you have to watch out, right, for being too skeptical, at least in some situations, and you have to watch out for sort of how you set that up. And one extreme here is Descartes. So Descartes was writing at the beginning of the scientific revolution, right, and thinking about all the ways in which the beliefs of Western Europe at the time sort of had gone wrong, right? So they discovered a whole bunch of new things about anatomy. Sort of, you know, we've got Copernicus, and sort of we got a whole bunch of sort of revolutions in science. And he's thinking about how can we go about making science like really well-founded, so that we don't have these reversals. We don't have to sort of go back and say, oh, we were wrong, right? And so what he wanted to do is he wanted to set up the highest level of skepticism possible, right? He said, I'm not going to believe anything unless I'm absolutely sure of it, right? Now, all right, well, what happens if you set up that standard, right? Well, you have to do things like, I think there's a table in front of me, right? But am I absolutely sure? And Descartes was worried about, what if there's an evil demon messing with me, right? And there's no real world out here at all, but like he's faking me. Right now we would say like, what if I'm in the Matrix and this is all a virtual simulation, right? You know, and you go like, right? So, well, I'm a skeptical person. I'm not going to believe something without evidence. And so then you ask, all right, so what's the evidence that this is real? And you go, well, I hit it and I feel it. Well, like there's alternative hypotheses that would explain this, right? You know, you're in a matrix and it's not really real, right? And you go, oh yes, oh yeah, no, so I'm not sure of that. I can't prove that the table's there, right? And if you're too skeptical, then you have to even doubt the reality of like, you know, the people you're sitting next to and talking, right? All right, so that's just showing you like an extreme version of skepticism, thinking about only type 1 error, right? You don't want to go and believe something when you're wrong. Where I got to say, in terms of like the reality of the external world, I'm really worried about type 2 error, right? False negative. I don't want the world to be real and not believe it. That seems like that would be bad, right? You know, car coming towards me, and I'm like, what's my evidence that that's a real car? I'm not really sure, right? Like, let's wait till it's, oh, yeah, okay, oh, that was real, right? Okay, so I don't want to be in that situation, right? You don't want to be in that situation. You don't want that extreme version, right, of skepticism, right? So how do we balance? Well, it is a balance, but let me say one more thing to argue ways in which I think you should be very conscious about that balance and very deliberate about that balance. And one of these ways is because the way we think about this can be easily shifted by climate, the climate around us, the context, the way people are talking about framing. And here's one example in which society's standards of evidence and how they were trading off type 1, type 2 error, false positive, false negatives was shifted in ways that I don't think was for the good of society, and I don't think people would have all made had they like consciously and deliberately been weighing these, okay? And I don't know how many of you are familiar with this. Have you heard of Doubt is Their Product? How many of you? Okay, and Merchants of Doubt, have you heard of this one? Okay, I'm going to put that link up, or that indication up for you too. So this is a discovery of a document by a tobacco executive that I think is unknown, anonymous, right? So it was just like internal documents, right? From a marketing firm, I actually think, right? And what it said is that, look, we can't, at this point, the evidence is significant enough that we can't argue that smoking the tobacco is just safe for you. Like, there's a bunch of evidence that it's, that there are problems, right? But what we can do is ask whether we're sure enough, whether the evidence is strong enough for us to start regulating. What we want to do is manufacture doubt in people's minds, right? So what happened then was like, oh, there's all this evidence that, right, tobacco is carcinogenic, right? That smoking, right, causes cancer, right? And then, well, wait, are we sure enough? Are we sure enough that it makes sense to regulate, right? And you can keep on asking the question, are you sure? And notice what that does. As soon as you frame those things, you start paying attention to like that false positive, right? And oh, all those negatives. But you're not paying attention to the other, right, costs. The cost of like, oh, it is, and we're not regulating it, or we're not taking care of it, or whatever. It's really easy for these lines to shift in ways that we are not attentive to, and in ways in which you are not actually deciding. Okay, and this book, and there's a nice movie that goes along with this, indicates how actually the very same people who are doing that for tobacco are also doing it for sort of a whole bunch of other cases, including then for climate science, right? And sort of the like, oh, are we sure, right, has been a thing that has been intentionally done, right, to shift our standard up to be paying attention to that one problem, right, at the cost of us not paying attention to the other problem. Well, what if climate change is actually happening and we're not like acting on it? Well, right, sort of which would be worse, right? And there's not, if you just let things happen, you're not having a nice conversation, a legitimate conversation about values. When there's value trade-offs, as I'll get to in a moment, there's no way around it but like weighing the values and thinking about them. You can't just let it happen, right? Because it's really important to the decisions that you make. And let me just sort of note in recent political history, I haven't done actual work on this, but so this is just me sort of as a citizen of the world paying attention. The hearings for the seating of Brett Kavanaugh on the Supreme Court, right, where the issue was what's the word? The challenge, the criticism, not the, what the heck is the word? Accusation, thank you, that's the word I was looking for. Nicely done. Right, so the accusation made against him, right? And if you go back and look at some of that, you'll note a lot of basically criminal justice standard talk, right? Oh, innocent beyond innocent until proven guilty, right? Beyond a reasonable doubt. Oh, we don't have enough evidence, or we're not really sure, right? And I just want to note that I didn't see much, if any, discussion about whether that's the right standard to be applying for a question of, right, seating somebody on the Supreme Court. This isn't a criminal justice hearing, right? It's not, it's not putting somebody in jail, right? It's elevating them to a position of power, right? And arguably, at the very least, you want to have a conversation about what the right standard is, right? Sort of, if you think there are uncertainties in this particular case about this accusation, right? Well then, how do you weigh those uncertainties? Like, don't just take a standard from criminal justice and apply it here, because that standard is meant to do certain things about the false positives and false negatives, right? That maybe aren't appropriate for this case. You should be thinking about that in a case like that, as you should be thinking about it in all the science that you do and all the applications of science that you do. Oh, and let me just give you one more example. This shows up not just in sort of the type 1, type 2 error in terms of like a particular thing, but it shows up in terms of like what measures that you're looking at, what outcomes you're looking at, what variables you choose to measure. All right, so this is a case from, I should back up here, from Needleman, who did a lot of work on lead toxicity, did some like really amazing work in sort of trying to figure out, especially in children, and sort of like, finding where we could find their early, well, whatever. So, all right, so one of the things that he argued was about the ways in which conversations about lead toxicity got shifted to what he thought were the wrong issues. One of the things he notes here, this is a graph of cumulative IQ, the percentage of people under a particular IQ level, right? Under these two cases, high lead and low lead exposure. And what he notes is, the 50% mark which if this is a Gaussian bell curve is going to be your means too, right? So the difference between the means of these two groups is 6 IQ points, which, IQ is not a good measure of like lots of different things, but it's a proxy for some things, and so, whatever else you think about it. Okay, so you might ask, what's the difference between, 6 IQ points? Like somebody's like got an IQ of like, 96 versus 102, whatever, right? But what he notes is maybe we shouldn't be looking at the difference in the means. Maybe we should be looking at what happens in the tails. So when you shift everybody in one direction, right? This is the highlight exposure. This tops out, like there's nobody, or very small percentage, right, of people in the high exposure cohort that have IQs over 120. Whereas in the low lead exposure cohort, there's like, another 8% of people, or whatever it is, right, above that. And then the same effect, conversely, on the tails, right? Now, in terms of like ethics and justice and values, like, if you just look at, like everybody's IQ is going to go down by like, whatever, like that should be a concern, but like, maybe it doesn't freak you out that much, but the effects on the tails maybe is something that you should go, whoa, like look at that. Like what kind of effect is this having on society and other things like that, right? And that is a difference in the variables that you're looking at and the dimensions in the variables that you're looking at. So it's really important. Again, like it would be really easy to shift one way rather than another thinking about that, okay? All right, so the lessons are you can't avoid values. They're there, you should be intentional about them and don't let other people sort of decide them for you, okay? I'm gonna really quickly do the flip. So that was about ways in which values come into science. And I wanna just like really, really, really quickly go through ways in which you can think about applying them, okay? So this is now a question about how do we use science to make decisions. And I'm gonna put this in the framework of decision theory, rational choice theory. I want to give us some time for questions, so I'm going to go through this stuff fairly quickly, right? So this is a standard way of thinking about rational decision making, right? I want to decide whether to take an umbrella to work, right? Well, how do I do that in terms of the consequences on me, all right? Well, note here, these are values. These are fake numbers. These are fake utilities. Like, I'm at a 10 if it's a sunny day and I left my umbrella at home, but like I don't like carrying an umbrella, so like I go down 2 utility points if it's a sunny day and I'm carrying my umbrella. But like I'm even unhappier if it's raining on me and I don't have and I have an umbrella, but I'm really unhappy, right, if it's raining on me and I don't have an umbrella. So those numbers are supposed to like reflect kind of, right, sort of, those are my preferences, those are my values, let's pretend, okay? So what should I do? Well, a standard way of thinking about this is like I decide what to do. I'm gonna do a weighted average and I'm gonna sort of see like what's the best thing for me on average on days like this, okay? Kind of makes sense. You sort of wait like this is, all right, so, and this is, in some ways you should, we see things like this and maybe you see, well, a lot of things like this, maybe you've employed it in sort of thinking about policy decision making, but this is a standard way of approaching rational decision making. 2 points. One is, what's the right decision depends on you and your values. These are the preferences that show up in here, right? And facts about the world, or at least what you think the facts are about the world, right? So if there's a greater chance of rain, right? You're going to be better off, right? If there's a less chance of rain, you're going to be better off, like not taking the umbrella, right? But that's actually going to depend on what your values are. So like if you really, really don't like carrying an umbrella when it's sunny, then like that's going to shift your decision making, okay? All right. I just want you to have the sense of this. There's nothing fancy or profound in what I just said. This is standard kind of stuff, right? What I want to point out are a couple different things. One is facts can help you better achieve your own values, your own outcomes, right? Sort of knowing more about the chance of rain sort of helps you achieve things. But facts inform decisions given values. The facts can't tell you what to do except given the background of what you want to have happen, right? Do you actually really, really, really not want to get wet? Or do you really, really hate carrying an umbrella when it's sunny, right? Well, the facts aren't going to tell you what to do except given the values. And this is a standard like the is-ought distinction. Sort of, there's a phrase here. You can't go from an is to an ought, just from ises. Like just from facts, you can't tell you what ought to happen. You need some values in there, okay? Which facts are relevant depends on what values. So do you care, how much do you care about getting wet? Depends, right? So which facts you're going to look at. If you don't care at all about whether you're getting wet, then it doesn't matter whether it's going to rain or not. You're not going to take an umbrella, right? So you don't need to know those facts. But also, what the facts are depends on the values, like sort of what, so, and this comes out in the following way. Based on everything that we just saw, the science that tells you facts about the world can be influenced by values, right? So like, let's take, for example, in this like simple case, let's suppose you have a weather modeling system that really does a really good job of predicting major events, but does a lousy job of predicting like drizzly rain events, okay? Now, if you really care about the major events like, you know, downpour, right, and not so much the other stuff, then the facts like saying, hey, there's this chance of rain, that's going to comport well with your values, right? But if you hate being even drizzled on, right, and the facts that come out of the, you know, out of the science, out of the weather prediction, the predictions, right, sort of are influenced by the particular model, right, or like it's cautious, it doesn't want to predict like major events, or it's over, like, it's over careful to like say that there might be an event, a major event, because like it wants people to be safe. Like, you know, that might shift your decision making in ways that you're not even influenced, like thinking about, because it's kind of been embedded in the science already. Right? Something to be paying attention to. And I am, so let me, what the science does is tell you, I'm going to skip the rest of this slide, but the science does is tell you sort of about information about this, what are the chances of rain, but, and also like what are the consequences of doing these things in terms of what's going to happen. But again, your values are on top of that, like that science doesn't decide those values for you, okay? And also, I want to point out that sort of how you compartmentalize this. Is this rain or no rain, or is it rains a lot versus rains a little versus, like that's got to be decided by your values too, right? Which of the things do you actually care about? And you can't just take the information given to you, format it a certain way, with a certain set of variables, et cetera, and let that format your decision making, right? You want to think about sort of what is it that you care about first before you find the right science or facts to tell you about that. And I'm going to leave you really quickly in just a couple minutes here with a really big question, because this was just about decision making with respect to your own values. We're in a society, we have to make decision making with respect to a whole bunch of different values where people disagree, okay? So what happens there? And let me just tell you the main lesson. The main lesson is going to be that when you're thinking about value disagreement, science ain't going to help you at all. This is all sort of a social, ethical, and political issue. Okay? So like what happens here, and these are rankings now, forget about the numbers, if like one person really, really, really hates to be rained on, right, without an umbrella, and the other person really just like the worst thing that could ever happen to them would be carrying that damn umbrella around when it's sunny. They just hate that, right? It just ticks them off. Now, if there's one umbrella for like the two of you, if this is, you know, you and your partner, right, and you're like gonna, like you've got one umbrella and you're gonna be walking to work together, like how do you make this decision? Now you're kind of stuck, right? I mean, this is all right, and there's an issue here. Is actually given a whole bunch of people with different values, there is no way to collectively decide what our values as a whole are. There's results called Arrow's theorem and Sen's paradox that sort of are in this area of showing you that, like, look, if we have a whole bunch of different preference orderings, there's no preference ordering of the group that meets at least a certain set of criteria. So you can't just sort of vote, because, like, never mind the fact that some people are going to lose and whatever. There's like, it doesn't even, there's not even a way to just vote and sort of decide what our values are, right? Disagreement about instrumental values, the things that like, will this help you get to there? Those can be decided by science. Like, does studying help you, right, for this kind of test? Or does, like, you know, do umbrellas keep you dry? Well, yeah, I mean, sort of like, so if somebody's like, no, I don't like umbrellas, they don't work, like, you can do a study and sort of like, no, look, there's a value to an umbrella, right? You know, here, I'll show you how much drier it keeps you. And so you can adjudicate those things. But you can't adjudicate fundamental disagreements by science, okay? And you can't adjudicate collective action problems by science either. So there's these two separate categories of where we just fundamentally disagree about things, or the categories that look like this, where we agree about things. Right, this is a prisoner's dilemma or a collective action problem, and I don't know if you've ever seen these things, right? Sort of, but these, right? So yeah, okay, right? So like, so, okay, so science can't adjudicate this either. This is a case where we have some set of values in common, but because of the way things are working, right, our individual decision making is going to tear us apart. Science doesn't just help us like decide this thing, right? And we agree in some sense on what the values are. We've got all the same sets of values, right? But there's mechanisms via which like the actual actions are going to send us in ways that sort of go apart, right? Okay, so now the lesson here then, both for these kinds of situations, collective action problems, we agree on values in some sense, but there's mechanisms that are going to be such that we can't all achieve the values the same way, right? Or we fundamentally disagree about outcomes, right? And there's no way to adjudicate those via science. These are things that are inherently value questions. There's no easy solution like just vote. There's no easy solution by just like, let's get stakeholders involved and do it, right? And sort of decide things like which stakeholders, how much influence they have. I mean, you know these are messy things, right? Sort of what I want to point out is just ways in which these are, you know, inherently value-laden questions that affect not just, I hope, right, the lesson is obvious, not just the policy decisions that are made, but like really, if you're thinking about sort of particular policy issues that might happen, like you got to be thinking them from the very beginning in the science that's getting done, right? And now this raises this really hard question because like how do you get everybody involved in the science that's done from the very beginning? And how do you decide that stuff from the very beginning? Like that's impossible in many ways, right? And I just said, you can't just vote and you can't just whatever and you can't like, so this is like this inherently very, very, very difficult problem, right? And the main lesson is just don't try to avoid it, right? You got to do something about it, right? But be really attentive to it. All right, so time for questions.
So I'm going to pass this to people that are asking questions to make sure we have your questions recorded. Does anyone have questions?
I got one, but it requires the microphone to come far.
I'm not sure it's on.
Yeah,
It's on.
Let's see if we can get it, or maybe just pass it over.
So you spoke about these messy issues
Yeah.
to which there's no solution,
Yeah.
but we should think about them nonetheless. Reminded me of a lecture we had, I think, 2 or 3 weeks ago when the topic was political science,
Yeah.
and the main way forward was mentioned is empathy. We first need to understand the other person's point of view, and then together perhaps come up with a better solution. Would that be going part of the way, from your perspective, towards doing science in a better way so that we avoid some of the issues that you were mentioning today?
So,
and with whom should we empathize in that case?
yeah, well, and so the with whom should you emphasize is one of the main questions here. So here's the way in which I think this is really important, right? Sort of because, like one of the things I just said is you can't get everybody all involved in the very beginning, right? You can't, like every time you want to start a new study, sort of get every stakeholder involved and then decide how to represent and sort of and what what aspects of the science are you going to have them decide on, and what do they actually understand about the science rather than the consequences, and right. So one of the things that you can do is, as a scientist or as a somebody in science policy setting or whatever, right? Take some of that on yourself, right? So that's one way in which that can matter, right? So which is probably not what was being said there, but try to think about what the other people's values are, and use them in your decision making, right? And do your best at sort of trying to understand that. And this is a challenge because your scientists' expertise are not in public values, right? Are not, and in some sense it shouldn't be. They shouldn't sort of like, every time something's happening, like, well, what's the latest poll on like what people think about this or whatever? You shouldn't be that, right? But on the other hand, right, you want to be thinking about what are going to be the best outcomes, who cares about this, who's going to be affected, right? You want to be thinking about that, and at least one way of thinking about that is empathy. Now, the other part of that is in communication, right? Is in the deliberation of value disagreements, right? Or in disagreements, say, about the science or whatever, right? Sort of understand where they're coming from, right? Don't just tell them, here's the answer, right? Sort of, but understand why they think differently from you, right? And so that really matters for communication, I think, for sure, too, also. But I would argue has to be up front, too, in you're deciding the science that you do. Does that make sense? Yeah.
So I was kind of curious about what you thought of the process of science feeding back to the scientists themselves, because the scientists are, thinking, feeling people that have values and want to do science
Right.
a certain way, but when the institution or the way things are done or the lack of action on some information you've discovered or found really important for the benefit of humanity, for whatever, what does that do? How does that come back to the scientists themselves, and how do they struggle reconciling their values with kind of the values and position of the system around them?
Yeah, so this is a really good question in terms of it hits lots of things, right? And like one of the things that I think is important is to think about the ways in which our institutions and incentive structures incentivize certain kinds of work that may either not be for the best for everybody or maybe not the best for the the person, right? So like you got to publish, and sort of part of the blame for the reproducibility crisis that people are talking about in sort of a lot of areas of science is put on at least partly this like need that a lot of scientists feel to publish, right? And then just to do something and not necessarily be doing the thing that like they think is most valuable or whatever. And like this is like for grant getting and everything like that, right? So now this is a really it hits a lot of things. So one is the incentive structure, and the other is sort of what sorts of things are legitimate for you to be like thinking about as you're doing the science, right? So scientists are people, right? And you choose a career for a particular reason. You do the kinds of things you do for particular reasons, right? Properly done, there's a way of thinking about the processes of science that are meant to both, like the ideal version of science is probably the one that would both take advantage of the actual interests and capabilities and whatever of the scientists, right? And then mitigate the worst impulses, right? So like, you want to get famous, so like, oh, you've got this impulse to like, slightly adjust the data, but then there's going to be peer review and they're going to knock it down, right? So the best institutional structures would be ones that harness certain things for good, right, and tamp down the others. I think one of the issues is that those don't always work in either of those two directions well, right? And so some of that then has to do with sort of like the scientist, him or herself, right? Sort of how comfortable do they feel in a particular institutional structure or working for a particular cause? How good do they feel working for like to produce information that will help for particular causes, but like really step away from like maybe advocacy if they think that would subtly influence their work or influence people's perception of their work, right? Versus like find an area where or find a way to advocate where they think it won't, you know, wrongly either influence their work or people's perception of their work. And I think, you know, again, sort of one of the issues is maybe there aren't really good models. There are a lot of models of scientist advocates, and sometimes they get, in some areas of science, they're not looked on well, right? Sort of if you're too much out there doing advocacy and you know, public outreach and things like that, then you're not serious enough about your science. And that might be like another version of this that is complicated. So I think there's lots of factors in there, right? That I think in the ideal version would let the scientists do the things that they want to do and find the place, but we maybe don't always have the right institutional structures to harness them in the right ways.
All right. Thank you again.
Oh, is it? Okay. Thank you.